You have your serious face?
I do have my serious face. So it's just even my smiling face is my serious face.
All right, this is multimodal, so this is the next stage. All right, I'm not gonna show that. All righty. All righty, we are getting set up here. How do I make this go away? I will, I don't know how to get this away. Put it to this other screen here. Cool. All right. What's up, YouTube? Back again with another banger. Ah, like you know how they do the transitions? There you go. You're so small here. How do I make you
Yeah.
a little bigger here? Oh, that's too big. I'm just gonna have to make do with this little small face. Oh, that's okay too. Alrighty. I don't know how to make you smaller. Ah, damn. I guess that's it. Cool. Put you right here on the top right corner. All right. So this presentation um, was brought to you by me, Alec Moldovan, and the whole idea for this presentation was to actually document what I did for this hot Latina here, Alondra. And she is a non-technical, non-AI. You can call her a mug, possibly, right? In the Harry Potter world, for the Harry Potter fans out there.
Yes.
So I am introducing her to the world of magic, of retrieval augmented generation. So here in this environment, in this atmosphere, we did daringly design a project and we execute very cautiously, right? We have to be meticulous on how we implement and making sure our program does not crash. So I'm going to skip this little prelude because we are not in a fiction world here. We're going to get right straight into the nonfiction section. So here's an overview of to get kind of the appetizer of what a RAG. So RAG is retrieval augmented generation, and it is a system that when you have, you know about large language models, it's this black box that seemingly is smart enough to reply to us when we answer questions. However, sometimes it falls short as if you are a ChatGPT user, they will probably say that this was trained up to a certain date. So that means they trained their neural network up to a certain date of all the data that they had available from the internet. And at some point, you might ask something that is beyond that date, and it will just hallucinate and it will answer you very confidently, oh, such and such, such and such. But you can verify that it is complete, completely lying. So, to put it nicely, I was thinking of a different word. So here, what it takes to create a retrieval to a RAG system. Okay, so then with the RAG system, it is, you could say, it used to be, maybe I would have referred to it as a poor man's way to optimize an LLM. Like let's say optimizing ChatGPT to be able to serve reliably grounded truth if you are able to, let's say, add this context, add the documents into a storage base. And then it's able to say, okay, hey, you write a query, and then it says, okay, I have some context that was added recently. I can refer to that, and you don't need to train. So it's in a way it's keeping the LLM still relevant and you could say up to date because you added the context, right? You added it in there. So it's like a poor man's way, but it's getting pretty strong. It's proven to be quite competitive against, let's say, retraining the whole LLM again, because retraining, especially when you probably hear in ChatGPT or even the Llama 3, you know how open source LLMs, 405 billion parameters. the lowest one is 8 billion parameters. And to think about trying to train it every single time if you just have a laptop or you just have consumer grade GPUs or CPU for your computer, this is like is not feasible to do that. Right. So this is a great workaround. This is something that I was able to develop within a laptop, which I have a very mid-level um, an old computer, you could say. I probably have a reference here of actually my system. I can show you here to put it here. Where is local thing? Boom, boom, boom. I have it here, GPU specs. There you go. So right here is my GPU specs. Just if I zoom in a little bit more, let's make this bad boy a little bit bigger here. Right? I only have 6 GB of RAM on my GPU, and this is a 1660 Ti, and which means it's on the older side. It's probably like 2 years old, and it's already, the world moves very fast, and that can become obsolete real quick. I'm starting to feel it becoming a little obsolete, a little bit low key, especially now doing this AI development. I was running into out of memory issues, as Alondra knows. I was complaining or whining about it earlier to her about it. And so the out of memory issue is happening is because of this GPU memory. They've misspelled it here, but because it's being 6 GB. And because what happens is when I start up the system, and I might have out of memory GPU again, but I fixed the thing. But what happens is it tries to hold the whole GPU or the whole LLM model and maybe other things that are relevant to do its function within that 6 GB. And when you're having 6 billion, 8 billion, 405 billion, it goes way over the 6 billion mark. So that is a problem that takes a little bit of a magic sauce, and why AI engineers get paid the big bucks to make it work. So, right, instead of relying purely on a pre-trained language model, this is what I covered. So, a RAG system, um, retrieval augmented. So that part, there's like four specific steps related to the retrieval part. Well, let's say to be really technical, three. But in general, to be really broad, five, right? First is to get raw data creation, right? If you put garbage in and you don't, right? If you're, let's say you give it the wrong document, then it's gonna not know to answer that, right? That's the most trivial case. But let's say you gave it the right, in this case, in this use case, we gave it the right website to scrape data from a website and all the web pages. We gave it the right website. Now, how are we going to prepare that data? The pre-processing part. How do we parse, in a more technical term, parse it or extract information that is relevant to question and answering, right? If let's say we have a less tech savvy person and doesn't really want to navigate and wants to just has a frequently asked question, they could ask just the chatbot right there, probably as a little widget on the bottom right screen that usually shows up on front pages for landing page. Then you say, hey, some question. And then that it is supposed to have been prepared in a way that was able to extract all the information to answer your question. The next part is pre-retrieval. So when it comes for pre-retrieval, this is the part where you're talking about chunking the data in a certain way and how you're creating the index structure. So in this case, what I did for this proof of concept, I went beyond a little bit of the naive approach of just setting up a vector database and just chunking it with what is usually the de facto, the go-to recursive character splitter. I used a thing called, it goes a few different names. One is called an auto merging retriever. Another one is called a parent document retriever. So I'm still using the recursive character splitter, but later on I am using another one to create child chunks and bigger chunks, parent chunks and child chunks. They have a correspondence with each other, and this pre-retrieval step, kind of how you index it, kind of feeds into the post-retrieval part as well. They're kind of like there's a bit of an overlap, like it has a direct impact on this part. So that's the retrieval here. So if I click here, oh, it's supposed to expand. What I was just talking about is this. Let me bring that over here. I was just talking about this. So here's your website to scrape, right? Your URL. Then you scrape it. So this is using like Beautiful Soup. That's one of the libraries you probably hear about. Or I don't know, Selenium. Beautiful Soup is usually your go-to. Then you get your documents. You get a bunch of, usually they're HTML, so you're probably going to get a bunch of HTML files. From the HTML files, you start creating the child chunks and then the parent chunks. And then you encode those child documents or child chunks, I have to update that, into a vector database. What is a vector database? So the first term is the biggest clue. A vector, as we would learned in pre-calculus, calculus, and linear algebra, this is a mathematical concept, is let's say you have a graph and you have your x and y, right? So right now you want to pay attention to me.
I am
So
paying
no, 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 this is not for you, for the listener. You will have a point in this X and Y. That point will, let's say, has 2 dash 1, right? 2 on the X, up 1. That is a vector because it shows you the direction of where that vector is pointing at. So it's kind of in the sense that imagine having that is two-dimensional. Now with a vector database, there's many different ways on how this is done. What's not mentioned here, and I can update more, is that to encode, we're encoding text document, so it means to transform a word and transforming into a number, a floating point number, and putting those together as a vector. You know, like right 2, so it'll be 2.0 dash 1.1. You know, that's the direction, right? So it can use an embedding model. And funny enough, that's actually another little AI actually at work here as well. There are many different types of embedding model. You can even fine tune it, which means kind of like train it a little bit as well as we learn training. You can fine tune those to be working very well in capturing the meaning and the context of the document that it retrieved, right? Or that is encoding, right, from the child chunk. So I can repeat that again. An embedding model will be able to read, take, let's say, a sentence, transform that into a vector, right? Into so many different, into X amount of dimensions. We were talking about 2 dimensions. But with embedding models, there's many different types, and you can go from 2 dimensions all the way up to, I don't know, I've seen 700 dimensions, high dimensional. By doing high dimensional, it gives this ability that is able to capture the meaning of the sentence in a way, right? It's able to have a better semantic capture of the thing. It's really, yeah, this is the magic part, right? How can you say like you have a sentence and then it's like it captures the meaning and it transforms it into vectors and then somehow that means something? Well, as far as my knowledge can go, that is how it works. And so then it puts those vectors all into that database, the vector database. So we have our child chunks, the child chunks in this parent document retriever system. This is not a non-naive approach. A naive approach would just be you just have the documents and then straight to encoding it. Here in this case, we are keeping we're making child chunks, smaller sentences, and then we have bigger sentences that contains these little sentences in that as well. And then we're encoding it, and we're also, probably here you can see it, we're having the document storage. So this is containing the parent document that contains the little child documents that correspond to parent document number N. 1, 2, or 3. So you have child document 1, child document 2, or the chunks. that goes still relates to one parent document, and there's some overlap in between. And so the parents are going to the document storage, the bigger chunks, and the child are going to the vector database here in the vector database. So, so yeah, so that's the part. So you get the user interface document. Okay. So when you get the post retrieval, right? Coming back here, when you get the post retrieval, so you get a user input, a query. It you also encode. So believe it or not, this is what's happening too. You are also encoding, translating into a vector, and then from there is trying to match from your vector of what you're asking, it's trying to match the closest matching vector, right? The child document. It's trying to match that. Once it matches the child doc, right? Match the encoded query with the closest matching child chunk, then it it found the child chunk. That child chunk is supposed to correspond to a parent document. So it goes back to the document storage. Hey, I have this child chunk ID, which for this child chunk, which parent document contains this little sentence? Then you get the parent and you get PN, a bigger context, sent back into the retriever. The retriever, in this case, I also implemented a re-ranking top K results. And why I put this here is that there is a caveat with LLMs and how they work. And let's say you wanted to return 10 or 10 plus different sources of data. So you retrieve 10 or 20 different parent documents, bigger chunks back. Usually it'll go from 1 to 20. However, the problem is that LLMs, there's an effect that happens that is called lost in the middle. An LLM, when it's generating a response that is using a prompt query in a context to generate a response back to the end user, it tends to favor um, in, any information that is positioned in the beginning or in the end of all the context that you get. So you need to re-rank it to make sure that when it's generating, it's still like you're like, let's say you extract and then you kind of extract again from all this context that you got so you can get higher and higher accuracy. The key metric, what I mentioned, is the accuracy or groundness to truth. It is very hard to achieve. So in general, as a proof of concept is very easy to make, and you can kind of get an idea like, oh, it's kind of working. But when you start getting to the deployment part where you want us to really deploy it to customers for a small business, then this gets a lot more critical, and this is where the magic sauce comes in again, of being able to evaluate your whole RAG system here and making sure that every change that you make or any added feature that you add in, because there's a lot more you can add here. There's more you can add here. There's more you can add here. Uh, there's so many points in this pipeline and all these little systems that you can add that contributes to this end result where you get here, which is a better response that is accurate to what is and is actually relevant to what that user asks for and and is needed. It fulfills the need of the user. That's the idea. So I went over a lot. You want me to go over anything again? Did I go too fast on other?
No, you did well.
Okay. So that's the idea here. So then we got to the generation part. So I pretty much, yeah, a picture is 1,000 words. We don't necessarily need to go into all this little nitty-gritty stuff. If you want, this might be published, accepted by the geek culture. We'll see. This is where I mentioned about parent document. I think one thing to say is the efficiency actually reduces. Let's see here, breakdown. What part of my bonus? Unnecessary rework. Oh, I just talk about recaching it. I talked about the recursive character text splitter. So you see child splitter, parent splitter, right? And then you have your little overlaps here. That's the presetting, setting the index structure here. Here I just talk about caching. So every time you want to run the document, it doesn't have to rerun the whole thing because it takes a long time every time to create that vector database to rescrape and then encode all that step to parse it up. It takes a long time. So you said, right, reduce startup speed, efficient querying, scalability, the heart. See, there's a little bit another idea about the parent, right? You get the query, vector store has all the child documents, it gets the top K relevant child chunks. Then based on that, it finds that, oh, hey, this parent chunk has these little chunks in it. So then it gives it that. It doesn't give this one because it only had one. So it only gives the one that has the most. And then it gives it to LLM and it gives you an answer. So that's another diagram to give you a better sense of what's happening. And so then you're weaving the context. This is where I talked about this is what I use for the reordering because of the lost in the middle effect, lost in the middle effect right here. And that's the thing, it favors. And then generating. Now we're talking about generating the response. Right here, I use this llama. It's a 1 billion because it allowed me to be able to do it on my little puny 6 GB. Is that a question?
No.
Oh, I thought you were raising your hand for a second. I saw your hand.
Keep going.
Please refrain and keep your questions to the end of the lecture. I use this one because it was able to be, it's quantized. I use unslots because it's quantized. Quantized means, okay, we're going a little tangential here. Quantized means is that I talked about floating point numbers. Do you remember that, Alondra? About the vectors, floating
Yeah.
point numbers.
Yes,
So I
yes.
talked about 2.1, right?
Yes,
That's
the simple
point
one.
one. That is one digit after the decimal point. That's one significant figure. When you're talking about neural networks, they will have their floating point, the same thing, but they call them weights. So for each little node, right? This is one node, and then there's another layer, and there's many nodes, and then they're connected to each other. There's many different layers. Each of these nodes has a linear equation, in a sense, and in front of those is the scalar coefficient, and that is also a floating point number, and it has many significant figures after the decimal point, many digits after the point. So it's not just 2.1, it's 2.1, 2, 3, 4, 5, up to, what is it? You have floating point 64. So you can have to 64 byte. It can be very long. That takes up a lot of memory. Each digit takes up a byte, 8 bits. That adds up when you have 1 billion, 2 billion, 8 billion. That's going to use up all your GPU, and then you're going to have an out of memory error. And so that's why there's a lot of also, this is a whole other domain where you want to choose the right model that will produce a good response, but is also that doesn't require as much hardware to run it. So there's always this trade-off between performance, accuracy, and then how much resources does it consume. Is you're always going to have this. And so with quantization, what essentially it does is that instead of having a floating point 64 or 32, which is very large, it would truncate it, meaning cut it off, and then you only have it like maybe 4 or 8 digits after the floating point number, which can drastically reduce the amount of GPU memory that you're using at a sacrifice or performance, right? It might hallucinate a little bit more, or it might, yeah, exactly. It will hallucinate. You have a higher chance of hallucination, but you're able to run it on a smaller, more resource constrained environment. The idea. So I use LangChain as the framework, and it talked about the Lambda. This is where I'm searching the questions here. I want to get 10K like that, get the document. This is more of a getting a document, and this is more of concatenating and putting as sources as the metadata, and then printing. This is more like debugging. So optional deep for debugging, like I said right here. Here's the whole sequence. So using LangChain, they have a thing called LCEL. I think it's called LangChain Expression Language. That's what it stands for. And this is what it does. The idea is that as a developer, this makes it easier. I will agree. It does make it easier where this is like the pipeline. It's a little bit more. You can just insert each part, right? So here's the retrieved documents is concatenated. Here's my prompt that I told it to be a virtual assistant. Then I print, this is the debugging thing. So it'll print out my prompt. This is the LLM that will use the query, the context, and the prompt to generate the response that will be outputted as a string to the user. using this little string output person. All of these things can be swapped out with more custom, perhaps more robust components. That's the whole idea. These are all components in this whole pipeline. That's the whole idea. Prompt prompting, all these I put in there in the document. Some of the pitfalls, right? Risk of scraping. This is some of the things you need to address. Is not comprehensive. This is not everything, but these are the things that I considered important. So risk of scraping irrelevant content, right? So tuning the parser. So that's the part, the raw data generation and preparation. Making sure that the scraping part, this is even before any AI is in the picture yet. This is just software engineering. Making sure your beautiful soup that you're using this tool to scrape from the internet, this website, is engineered, implemented in a good way that it's able to take out the noise. You want to scrape out noise. This could be like, let's say if you just want a text-based RAG and just, you want to just scrape text, then you want to take out images. So you don't want to feed in images into to your knowledge base because that's noise. That will just screw up the RAG, the system. Pre-retrieval, more aggressive chunk. So you have to play around with the child, right? That you can play around with how big the child chunk is, how much is there an overlap. There's a lot of things, the parent, all that. Retrieval, memory constraints, use the GPL probably site for the vector. So that's the retrieval, that's the embedding document. Pre-ordering post-retrieval, use a transformer to reorder it. That's one thing, loss in effect middle, and then such and such. Next, I'm right now gonna be experimenting a little bit more with the query expansion. So this is pre-retrieval step. And then I will be messing around. I want to be implementing a RAGAs as an evaluation metric, evaluation system. So I want to systematically record and track if maybe based on a test data set of a bunch of questions and answers that are grounded, that are known. Did you message me? Oh no,
No.
someone just joined Telegram. That's it. Just gives you that stupid notification. Um, that that I'm going the right direction, right? If you're testing it, like, okay, I made a change. Okay, let's test it on the data set. Okay, boom, boom, boom. Okay, how grounded was my RAG? What's my accuracy? What's my precision? What's my recall or the F1 score? Yada, yada, yada. So, so I'm going to be messing around with that. And then the next one is going to be multimodal. All right, little demo time. Um, a little excited for that, are we?
Hey.
Is there any questions, Alon?
Uh, no. Not that I can think of at the moment.
Okay, I might not have this anymore.
I do
I
have one
think,
question.
yes.
Would you ever consider yourself being a professor?
No,
Yeah, I think you have very good teaching skills.
thank you. Such a dork. All right, I forgot my commands to get it all up and running. I should have made a make file.
Oh,
That would
I
have been a smart thing for me to do. So I can just do make and run and boom. All right, let's see. I have it somewhere here. Yep. Okay, let's get this bad boy running. And then the next one is Python M ACT server, I think. And then mock website, and that's gonna be on port 8000. This command might be so wrong. Shit, it was. It's hard when you're working on so many AI stuff and then you forget the simple little,
the basics.
yeah, this little commands. It's annoying as hell. So that should be running, getting it up and running. I want this. Oh, I probably want to be in the mock then. Yeah, I want to do that then. Yeah, that works. Okay, cool. So I have this little thing, localhost 8, not local clubhouse, localhost 800. So I'm supposed to have, right, this little thing here. See this little guy? It's my little chat box there. Okay, so it should be up and running. It's going to take a little while because as you can see, I'm going to bring up this little NVIDIA thing, right? See how much memory I'm using now. I'm at 200, it's still running it up. And you're going to see this grow when I ask it a question. So, because right now, what are some common dishwasher issues? And let you know, this is a proof of concept, not gonna work completely. Now it's still out of error because they're still waiting for this to run up. Takes a little while for the whole thing to run up. Let's give it a little second. That's my thing here. While we're waiting, I can show you what is running right now. So right now it's what it's doing with the whole app store. I'm here, I'm running this, and this is the, you could say the brains. Oh, now it's up and running. So here's the brains. I'm scraping this WordPress from appliance repair, and then it's initializing the vector store. I have it cached, so out of memory error. You see, it's still messing around with the out of memory stuff. Shoot. How much memory am I using? Oh, I don't think I might not be able to run it because last time this was at 700 megabits and I was
Hmm.
able to squeeze by with that. I could do this, but it would take longer. I could switch it here and I can make it be on CPU, or I can make this lower here. Oh, that's a little trick. See, now we're getting into the little gritty here. How much white? I have enough here. How much am I using? Five. Use five. That's close. I can bump it up a little bit. Maybe 6 gigabytes on the CPU. Okay. We're gonna we're gonna have to run a build on this. I believe that will be a build T. Shit. I don't know any of my document commands. Oh, whoops, did I misspelled it? No, I didn't. What is it? Sorry, Alondra. Let me get this working for you.
I feel like I'm in office hours.
Oh, I missed this little thing here. Okay, we're gonna rebuild it. Okay, cool. Okay, let's see if this works. Crossing my fingers. Because right now, what the problem is that I'm using already 1 gigabyte. So it's complaining about out of memory. What is it complaining about? It was just working. Requires a token. Oh. Where's my Alondra? I don't have. Wait a minute. Wait a minute. Wait a minute. Wait a minute. I need to see. Oh no, this was unexpected. Sorry, technical difficulties. I don't see my .env. I
What
see
is it?
.get. Oh shit, that's why it's complaining. Shit. So my .env is an environment. That's why. I rebased my whoops. .env should be there. Shoot. It's not there. Okay, so what is it called? What do I need there? It's called the Hugging Face token. Oh no. That's so annoying.
Can you get it back though?
Yeah, I might need to make a renew one, but it's just like a whole detour. So dumb. I just want to copy this, please. There's the copy. Where did it go? This thing is a little bit slow because where it is? Copy, copy, copy.
Yeah.
Cool. Okay, boom. I need to go to Hugging Face. I have to remake it. No. I might need to make a new token. Hopefully not. Token, 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 token. Access token here. I might have this stored somewhere here. I have this stored somewhere already. Might be in my credits. Yep. My secret token. This is going to be invalidated once I finish this video and upload it to YouTube. Okay, so that might be good. Cool. Support layers. Cool. I might need to put in string. It might complain again for not being in string. Langsmith warning. Yeah, we're not using that though. The Langsmith does not work. I have not gotten that to work. I don't know why. I do have that though. I have that there. Okay, let's see my GPU usage. One gigabyte. That's such a shame. I might not be able to do a demo. It's too much on my GPU already because it's probably because of the Zoom call.
Yeah. And it just said it's like less than 1 minute. So annoying.
No.
No, I know. I think you have to like make a second like part one and then part two.
Part two demo.
Yeah.
Okay.